A collection of Stuart engines and some other nice things. This one's part 2, a Stuart Grasshopper Beam Engine, which was built using a factory machine kit, looking at the overall mechanical condition. As you can see from this image, the engine is very well made. There is a subtle difference though between how the parts are made and how they are put together. Have a look at the drain cogs, they're a bit wonky, but that's not a massive issue. In this clip you can see very clearly that there are some slot-headed grub screws in the fittings for the valve gear. The rocker arm is held to the shaft using one of these slotted grub screws, and I wouldn't normally change them for the Allen caphead type at this size because they look wrong. I would just use some shortened hexagon head 7BA bolts instead. I'm not too excited by the crankshaft, it doesn't look too good. The end of the crank pin isn't very well finished either. What bothers me is the crankshaft should stick out a little bit from the crank web and preferably have a centre hole in it. Before attempting to run the engine, I'm oiling every one of the moving parts. As most of you will know, I have been doing this job a long time, and I can look at an engine and very quickly scan all the parts that I think are going to be wrong with it. When I first had a look at this engine, on a table in a house in Boston, Lincolnshire, I noticed that when I rotated the engine using the flywheel, the fitting of the flywheel on the crankshaft was a bit sloppy. And as I turned it, the engine didn't move, so clearly there was going to be a problem with this, but I'm not really bothered, most things are fixable. With the exception of a traction engine that someone's just sent me. More about that when I make the video. I'm just glad I didn't buy it, but then again, as I said earlier, I'm fairly experienced and I wouldn't have bought such a thing. As you saw on the Twin Victoria, the first thing to do is to remove these slot-headed grub screws. They are an abomination. They can only work successfully if the slot is below the surface of the metal that it's screwed into. This one was not very tight, so removing it was quite easy. I'm having a quick look in my box of Allen grub screws to find one of the correct length to fit to the flywheel in place of the slot-headed one. And when I found one, using an Allen key, I fitted it into the flywheel. And what is this? As I rotate the flywheel, there is another slot-headed grub screw in the other side. And this looks like it's been adjusted a few times. There are some marks on the slot. I wonder what this means. Why does this flywheel have two grub screws holding it in place? And even with the two grub screws, why is the flywheel still loose on the crankshaft? Note to people buying engines who don't really know much about them, it's going to be very likely that there is a problem with the flywheel. I've come across this many times. If the flywheel is not a good fit on the crankshaft, and this one certainly isn't, then you do have a problem. But if the flywheel is only slightly loose, you can get away with two grub screws to align the flywheel. And this will align the flywheel, even if there's quite a lot of play. But really it's an elementary bodge to correct a mistake. I tightened both of these grub screws to hold the flywheel onto the crankshaft. I think it's time to run the engine and see if there's any other problems. Because I haven't adjusted the two grub screws, the flywheel is all over the place. Time for a quick adjustment of both of them to centralise the flywheel. To give me some sort of a datum, I'm moving the position of the pulley so that the main bearing on the pedestal puts a bit of pressure against the flywheel, and that should give me a clue to its concentricity as I adjust it. Another odd thing that I notice is that the pulley is not concentric either. I'll correct this when I repair the flywheel. Putting this engine right will make quite an interesting short series, because what I will do is rebore the flywheel and sleeve it. Or I could machine another flywheel because I do have a casting for one of these. But I think I'll repair this one and repaint it too. The engine runs quite well, the rest of the parts seem to be fine, but the crankshaft and the flywheel and the pulley need some attention. You can clearly see that the flywheel is still loose on the crankshaft, I'm going to have to tighten these bolts, which means it may not end up in perfect alignment. Once the flywheel is tight on the crankshaft, the knocking noise should stop. After these adjustments, you can see that the flywheel concentricity is not perfect, and it's still wobbling. And yes, I am running this engine far too fast. I want to make sure nothing drops off it, and thankfully nothing did. But it does need attention. I can't live with it like this. I don't think the timing is perfect either, but I'm not going to mess about with it at this stage. I'm more concerned with just having a little bit of a fiddle with the flywheel to see if I can get it to run truer. Whatever I do with the grub screws, it's a bodge and I can't live with it. I did finally get the flywheel to run quite concentrically, but I would always know that it was wrong. What I'm doing here is removing the crankshaft, starting with slackening off the eccentric sheave. Then I removed the crank pin. Then I found that the crankshaft was so badly marked that the only way I could slide it through the eccentric sheave and the main bearing was to use a file to remove the burrs. Here is a close-up of the problem. The crankshaft is a rattle fit in the flywheel, which has already been sleeved, but the sleeve that was used was too big for the crankshaft. Remember, this model was built by a man who was a physics teacher, not an engineer or a machinist. He wasn't a young man when he built this, and he probably used some parts he already had kicking about in his workshop. Before I even bought these engines, I had a close look at them, and that's why I found them to be so perfect, because with each engine there is a fault. And as I really enjoy fault finding and fixing, and making tutorials of course, they're perfect for the job. Here are the parts on the bench, ready to take up to the main workshop and do a spot of machining. But that's it for now. Stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.